Assalamualaikum students. Today I'm going to record the video for you uh, for solving mechanics exam, May-June 2022. As you can see on the screen, it's variant 2. The total time for the exam is 1 hour 15 minutes. MF19 formula sheet will be provided to you. Total marks of the exam is 50. The value of the G should be taken as 10 meters per second square. If the body is going upward, it will be minus 10. If the body is going down, it will be plus 10 meter per second squared. All the answers you should write to the three significant figures. If they are non-exact answers or angles, must be written to one decimal place. Let's start with the first question. Small, smooth spheres A and B of radii 5 and 3 kg respectively. The moment I started reading the first statement, it tells me it's a momentum question, and it is on the smooth plane. Initially, B is at rest, and B is moving towards B with the speed of 8.5. So initial speed of the A is 8.5 meter per second. However, B is in the position of rest. So what is the momentum of particle A? The mass is 5 and the speed is 8.5. And what is the momentum of B? It has a mass 3, but it is in the state of rest. So I have taken speed 0. So the total momentum before the collision is 5 times 8.5 plus 3 times 0. Now let's come to the momentum, which is after the collision. The examiner said the spheres collide. Now they collided, and after the collision, A continues to move in the same direction. So the direction is not changed. If the direction is changed, then definitely the speed or yani the V becomes negative. But it ensures that the body keeps moving in the same direction, maybe on the right hand side. So in the same direction, but with the quarter of the speed of B. So if the speed of if the speed of B is V, what is the quarter of V? It is called 0.25 of V, or you can write 1 over 4 V. So the total momentum of a particle after the collision would be mass times its quarter speed plus the total momentum of particle B will be the mass of B is 3 and it is moving with the speed of V. Got it? So we have only one equation. We can solve it manually, or we can do this whole thing on the calculator by using equation solver, as I have already explained it to you, plus 3 times 0, and then you put the equal sign, then 5 times 0.25. In the place of V, you write X, plus 3X, and then shift solve. It tells you your V is equals to 10. So 3 marks you can easily get from this question. Sometimes examiners connect energy with the momentum question. So definitely when the particles will collide, they will lose some energy. They are moving on a straight road, straight line, so there is no potential energy. They have gravitational potential energy. They just have kinetic energy. So at the time of collision, what was the total kinetic energy of the system? So the kinetic energy of A was, since it was having a mass m and its speed was 8.5 meter per second square, so the total kinetic energy of A was half times 5 times 8.5 square. However, the particle B was in the state of rest. So half times mass times 0 squares. So no need to include it. But this is the total kinetic energy before the collision. After the collision, definitely some of the energy will be lost into the air in the form of heat or sound energy. So definitely now I'm going to have my final kinetic energy will be smaller. That's why I wrote initial kinetic energy first, and now I'm going to write my final kinetic energy of the system. So guys, you remember he said that it is moving with quarter of the speed. What we have found out, it was 10. So what is the quarter of 10? I just wrote 0.25 times 10 squared. Mass is 5. So this is the kinetic energy of A, and then the kinetic energy of B is half times 3 times 10 squared. So imagine Mr. Omer has written the kinetic energy before the collision minus the total kinetic energy after the collision. It will give us 15 joules. So 15 joules energy will be lost into the air because of this collision. So that was a very good starting question given by the examiner. Students will not have any problem to gain these 5 marks in their pocket. Now, the next question is also a very straightforward and well-known questions on forces and equilibrium. The guy said there are 4 coplanar forces, yani in the same plane, these forces are acting. And now he's going to ask you what is the magnitude of the resultant. Definitely when the 4 forces are acting at this point, so where the body will go and what which amount of force will be acting on it. So magnitude of the resultant and the direction of the resultant is required to get in this question. So you all know that whenever I want to find the magnitude of the resultant or direction, I need to get x net. So x net is all the right hand forces minus the left hand forces. How many right hand forces we have? As you guys can clearly see, I have resolved the 20 newtons horizontally and vertically. Also 16 Newton was resolved horizontally and vertically. You guys already know that in front of the angle is always with sine, the other one with the cosine. So I resolved it. Now I'm going to take x net, all the right hand forces minus the left hand forces. So you can see all my right hand force will be 20 cosine of 60, and my left hand forces are 2 forces, 16 cosine of 20, which was the component of 16 Newton along x-axis, and also there was a fixed force 14 Newton acting in the negative x-axis. So I wrote 2 minuses with them because both of them are acting on the left hand side. Some students, they just write bracket open and close. They can write, if you use the brackets, any parenthesis here, then you can write 16 cosine 50 plus 14. But my routine is if I will look at the force individually. If the force is acting on the left, I write minus sign. 14 is acting left, I write a minus sign. Once I get my final answer, it reveals to me minus 14.28. Do you understand? Minus 14.28 tells me the net X effect will be towards the negative x-axis. Got it? Now I need to find my y net. Y net is how many forces are acting upward? One force, 60 Newton, is acting upward. How many forces are acting downward? Here you will say, Mr. Omer, you said you are always writing the sign with the forces, but now you have used a bracket. Man, I want to give you both concepts. So did you see that I wrote negative sign and then I use the bracket? This is the sum of all the downward forces. So 16 sine 50 plus 20 sine 60. If you want to write individual forces, then you have to write minus 16 sine 50 and minus 20 cosine 60. I wrote them collectively, collective forces which are acting downward. So upward forces minus downward forces, it gives me 30.42. It is positive. It means that my y net will be acting upward. So now you can clearly see and feel that how your resultant will be acting. Your resultant will be acting in this direction. Oh, okay, under the action of all the forces. So what would be the magnitude? So your what is the formula for the magnitude? It's a Pythagorean, guys. Resultant hypotenuse is equal to square root of your x net square plus y net square. I substituted the values. Be careful when you're writing the negative sign under the square, it will become positive. So my answer is 33.6 Newton force is the magnitude the body will be experiencing. Now, how much is the angle? So look at the right angle triangle, which I have made it. I can easily find theta by using tan inverse of y net over x net. Please don't write the negative sign within the angle because I'm trying to find my angle as an acute angle, and then I will able to define which angle is made by the resultant with which force. So 64.8, guys, it is clearly seen. This is this angle, which came to me 64.8 degrees, and it is making with 14 Newton force. So which direction it is? It is a clockwise direction your resultant is making. Anyways, guys, this question is done. The next question is, it's a pulley problem. I'm going to move a little fast so that we can finish it as early as possible. And you can make more revisions. So particle A and B, you guys can see their masses are given and they're connected with strings, and the string is passing over the pulley. You know, guys, whenever we use string, the tension is produced inward the string, and the weight are acting vertically downward. The masses must be multiplied with 10 to write the weights. You can see the positioning of A, which is 2.1 meters above the ground, and 1.5 meter, the particle B is above the ground. Now, both systems will be released, and this is a system, so it will have only one acceleration and only one tension. The most likely question which examiner mostly ask that is to find the tension and the acceleration of the system when it is released. So guys, you can see now when you release the system under the action of, because the A has a more mass, so it will be going downward and B will be going upward. So if A is going downward, so 24 Newton will be bigger and tension will be smaller. So 24 minus T, I'm applying Newton's second law. F net is equal to MA. So 24 minus T is equal to 2.4 A. Okay, so MA, I wrote it, and then I reorganized the equation as 24 is equal to T plus 2.4A. And then after that, I went to the second equation for the B. Now B is going up, so tension is bigger and 12 Newton is smaller. So T minus 12 is equal to 1.2A. I got the second equation. And now I solved both equations simultaneously. You remember the simultaneous way? You go to the menu, and here you go to the simultaneous equations, and you know how to operate and get the value of T and A. Here I totally relied on the calculator. But guys, 1 mark normally examiner gives for showing the method. And as an A-level student, I am expecting you can easily show the method even by elimination or by substitution. That's not a big deal for you. Next question, find the greatest height of B above the plane. That's the tricky thing. Okay, first of all, look at the particle A. As you can see, I have given the heading. When you released A, it was in the position of rest. So I put U is equal to 0. You have just found what is the acceleration of the system, that is 10 over 3. How much distance the A covers when it goes down and hits the ground? He told us earlier it was kept at 2.1 meter above the ground. Now I want to see what is the hitting speed the ground, that is V. So I can use 2AS equation of motion. 2AS is equal to V square minus U square. So it gives you V is equal to square root of 14. Here is the beauty of the question is this speed will be inherited to the particle B because it is still connected with B. But B will not stop because B is not going to face any obstacle in front of it. A stops, but B will continue its journey under the action of Newton's first law, because everybody wants to continue its thing, whatever the state it has. So this V becomes the U for the next phase of the motion of B, which is a free fall motion. So now this V becomes as a U, so square root of 14. He said that in the question, the body will go to the greatest height. At the greatest height, definitely the body will stop. So V is equal to 0. Since the body is going up and it is slowing down, the value of G is minus 10. And I want to see how much distance will be covered by the body under the free fall. So again, I'm going to rely on 2AS is equal to V squared minus U squared. That gives you 0.7. So 0.7 meter is a free fall motion, 2.1 motion as A goes down, because A was 2.1 meters above. So B is also going to cover 2.1 meters up. And 1.5, why I put it over here? Because he said how much the B covers the distance. So B covers, first of all, this distance, which is already from the ground, it has 1.5. After that, in the connector situation, it will cover 2.1. And then in a free fall situation, B covers 0.7. We need to add all these three to get the total distance covered by the B to reach to the maximum height from the ground. Question number 4, you guys can see now a particle A moving along a straight track with a constant speed 8 meter per second. So the particle A is moving with a constant speed. Guys, you remember the constant speed formula? Distance is equal to Vt, and it is passes a fixed O. 4 seconds later, another particle is passing O, moving along a straight track in the same direction of A. The particle B has 20 meter per second when it passes O with a constant deceleration. So two particles are basically moving. First particle is moving. You see that how much the distance will be covered. Distance is equal to speed multiply time. The speed is 8 and the time is t plus 4. You will be surprised why, Mr. Omar, you have written here t plus 4. I'm going to tell you the technique over here. And the particle B, its initial speed was 20 meter per second and its deceleration is -2. So you see that I have used S is equal to ut plus half at square. Now the question arises, why, Mr. Omar, you used t and t plus 4? You know that this question says that the particle A starts from O. Okay, when 4 seconds gone, the particle A reaches here because A is performing a constant speed motion. Then after 4 seconds, a B particle starts its journey with a 20 meters per second from O. Now, both of them started moving to this side. Definitely at some point, they will meet each other. Now, either I can take the time when A started the journey from O, or I can take the time when B started the journey from O. This is on the discretion of examiner. Now, examiner has categorically mentioned that you need to consider the O after B passes O. So it means if B takes T time, definitely A will take T plus 4 time because A started its journey 4 seconds earlier. So if T is equals to 5, I will, for example, if T is equal to 0, I will substitute it here and I put T is 0. So it means that for A, it is T is equal to 4 and for B, it is T is equal to 0. Suppose B, if I put T is equal to 1, so it means that the B has spent 1 second. However, 1 plus 4, 5. A has spent 5 seconds in its motion starting from O. So I hope this can make you sense that why not I can explain to you if the examiner was saying, no, try to take the time when A passes O. So if A is here and B is here and B takes T time, obviously I will say that B will be taking T minus 4 seconds because it is starting 4 seconds later. So it is T minus 4. So when I put here T is equals to 5, then it will 5 minus 4, it will give you 1 second. If I put here T is equal to 4, so 4 minus 4, it means that it will take 0 seconds. So the whole thing, guys, depends upon what examiner requires from you. And you have to read every statement, every sentence given in the question carefully and highlight it. And then you need to model your equations. So anyways, I got the two equations and this is the thing he said you need to write in terms of T. I got the two displacements. The good thing in my working is you can see I wrote A in the subscript and B in the subscript. It tells you that I'm talking about A. If you don't want to write in the subscript A and B, that's fine. Examiner is actually looking at X is equal to 8T plus 4 and X is B is equal to 20T minus T squared. The next part of the question, he says that, find the values of the T when the two particles have the same distance. So same distance, remember, you found XA, put it here, XB, put it here, and try to construct a quadratic equation, and then you get the two values. So at T is equal to 4 and T is equal to 8, they will be having the same distance from O. Got it? Um, I can talk a lot about it, but guys, it's better to discuss each and everything in the sketch. Now, XA is a linear thing. So when you try to draw it, it will be a straight line. So I am just relying on my starter. My starter is what? When time is 0, substitute t is equal to 0, you got 32. When time is 20, substitute 20 here, 8 times 20, 160 plus 32 is 192. So Mr. Omar has just take 2 points and draw the straight line. This is easy. The XB, which is a quadratic curve, and you see that t square has a negative sign, so the face of the parabola will be downward. I converted it into the into completing the square form, which helps me to locate the vertex, the turning point. The turning point is at 1000. So did you see that Mr. Omar has made 10 and 100? By the way, you make use of calculator to write the completing the square form very quickly. How? I go to the polynomial two. I can enter -1 because the coefficient of t square is -1. Enter. The coefficient of t is 20. I'm going to enter 20. There is nothing constant there, so I'm putting 0. 20, where it cuts the x-axis. You saw the parabola is cutting the time axis at 20, and also it is cutting the x-axis at 0. So the first two strokes on the calculator gives you where the parabola cuts the x-axis. Okay, third stroke, this calculator will tell you the x coordinate of the turning point. So 10, and the fourth stroke will tell you the y coordinate, which is 100. So imagine Mr. Omar has this point, Mr. Omar has this point and this point. Another thing, why the examiner has made you to find t is equal to 4 and t is equal to 8, because these are the meeting points. So meeting points means both line and the curve should cut each other at t is equals to 4 and t is equals to 8. And this one, examiner will give you 1 mark in the marking scheme if a student has drawn the parabola and the line and both are cutting each other at this 4 and 8 second. Question number 5. Question number 5 is a straightforward ideal question on friction. So first I look into this question. It is 65 newtons and it is not acting along the plane. I need to resolve it, guys. So in front of the angle is with the sine, and this is the cosine. So I resolved it. Then weight component is always acting vertically downward. And I have to show, since it is the friction question, I need to also resolve it perpendicular to the plane. So this is 120 cosine of 24, and the normal reaction is upward. And be careful, guys, your normal and this component are facing upward and they are downward. Sometimes the students think normal is always equals to this 120 cosine 24. No, you need to consider the other force as well. Since this particle is trying to slide up the plane, it's not moving. It's like in limiting equilibrium situation. Limiting equilibrium situation says that particle is actually not moving, but the upward forces is equal to the sum of downward forces. So now what do you need to do, guys? The 65 cosine of 36, and there are two forces downward. Uh, this force is along the plane upward, and these two forces are along the plane downward. So I'm gonna just, guys, write F max. Everyone remembers F max is equals to mu n. Mu is a coefficient of friction, which is a constant thing, and I can find according to Newton laws, since the block is not moving up and down, so it means the sum of the two upward forces n plus 65 sine of 36 must be equals to 120 cosine of 24. Then I send it to the other side. I basically use this result over here for n. This is my n. Then I go to my equation solver and I got my answer. Mu is equal to 0.0529. You know how to. do this by making this mu as x in the equation, and you get 0.0529 to the 3 significant figure. Next question. Oh, wow, this is gone. Question number 6. Question number 6, examiner says that there's a 900 kg mass. It is moving with 11 meter per second. Wow. And it covers a distance of 150 meter above, yani it is moving up the plane, and it acquires a speed of 16 meter per second. Wow. If it acquires a speed of 16 meter per second, then definitely there is an engine fit in 900 kg. Okay, and he's going to he will be trying to engage the power into the question. So this is a power. Oh wow, power is given. How much time it takes from 11 meter per second to 16 meter per second? It takes 12 seconds. Guys, you remember power has two formulas. One formula is P is equals to FV, and the other formula is work done divided by time. So since the power is given, time is given, I need to use this formula. Which formula? Power is equals to work done by the driving force divided by time. So I make work done as PT, 24,000 times 12. Lovely. The beautiful work energy equation. What is that? Work done by the driving force, which is upward. Every time my students are asking, Mr. Omar, sometimes you write plus WP and sometimes you write minus P. Man, weight is downward. Your force is upward. So now if it is downward, your force is upward. Now I'm going to write a negative sign here. It's the weight is downward. Okay. Now, if the weight is downward and also resistance is downward, uh, which actually I want to find, and it is equal to the change in kinetic energy, which I am writing it as WKE. So come on, write it, guys. Power multiply time. Potential energy. How to write the potential energy? Weight component 9,000 times sine of theta. Be careful, guys. He wrote here theta is equal to sine inverse of 0.12. So I'm sending the sine to this side. It is equals to 0.12. No need to find theta. How much distance it will cover? Because you know that potential energy is kind of work done. Weight multiply with the distance covered along the plane. So 150. Resistance, I want to find work done against resistance. Kinetic energy, half m v square minus u square. And when I use equation solver, I can easily get my answer. WR is equal to 65250. Uh, Now, interesting question. The power is changed as by the examiner to 32,000 watts. It's a constant speed. Constant speed means the applied force, the driving force, is becoming equal to the resistance. And as per the question, the resistance is given to us. The resistance is given to us 1520 plus 4V, which is equals to F, and Ahmed, I'm in a class. So now F is equal to 1520 plus 4V. So since P is equals to FV, so power is equal to 32,000, force is equal to the resistance. I put it over here, and the body is moving with the speed of V. It is mentioned over here. Now, I'm just relying on the power formula, substitute everything. I'm turning up into a quadratic equation in V. It will give me the two answers. Negative answer, speed cannot be negative. So V is equal to 20 meters per second. Now, the last question, question number 7, he gave you two velocity formulas. From 0 to 10, the velocity is 0.5 t. From 10 to 20, the velocity is given as a quadratic expression of time t. Now, the examiner says, show that an instantaneous change in the acceleration at t is equals to 10. So t is equals to 10. There is a change in acceleration. So let's try to calculate the acceleration at t is equal to 10. From 0 to 10, guys, you differentiate, you get the answer 0.5. It's a constant acceleration situation. From 10 to 20, you differentiate the second expression. Guys, I get acceleration as 0.5. t minus 8. Substitute t is equal to 10 because I want to find the instantaneous change at t is equal to 10. So put t is equal to 10 into this formula. It gives me minus 8. Oh, wow. So we got a different acceleration. So if we got different acceleration, definitely at t is equal to 10, we are going to see a change in the acceleration. Another important point, which examiner mostly ask, how much is the total distance covered by the body from with the span of 20 seconds from 0 to 20. So I want to check that. Is there any rest situation happening from 0 to 20? From 0 to 10, I'm sure the body will not be going into the position of rest, because if you put v is equal to 0, it will give you t is equal to 0. So the body started its journey from rest. However, the second formula, I am not knowing when the body will be going to the state of rest, because finding distance, it is the must for the student to calculate the time where the body goes to the position of rest. So I want to check the rest. So put v is equal to 0 into the second formula for the velocity, and it gives me t is equal to 12 and t is equals to 20. Now, our time span from 0 to 20 will be divided into three phases: from 0 to 5, from 5 to 12, and then from 0 to 10, and then from 10 to 12, and then 12 to 20. Another important thing which you guys can experience, I have put it over here, the bars. Bars, you can use the apps feature of a calculator, which helps you to make your answer positive, because apps is absolute. So I want to take the absolute value. If it becomes negative, yani if the area is formed under the time axis, your answer will become negative. So I don't want to take any negative area or negative integral. So that's why it's better to put bars around, um, you know, around every integral from 0 to 10, from 10 to 20, 10 to 12, from 12 to 20. I need to take the integrations, guys. You already know what is the integration of these numbers. Then I need to put the limits. When I put the limit, did you see that? I got this answer positive, but this negative. But because of the apps, it will be changed to the positive sign. So the final answer will come to me 51 meters. So that's all, guys, with this exam. I hope you have understood. And if there is any confusion later on, you guys can discuss with me. Assalamu alaikum wa rahmatullahi wa barakatuh. Yes.